Today I would like to talk about one of my going project is to investigate internal transfer of PPCP and the passenger from the used water to the food plant. Currently, jaw is a big issue for us, especially this year in Illinois. In the summer, USDA lists 98 Illinois counties as primary natural disaster areas because of jaw. Water reuse is one of the solutions to mitigate the jaw. Using treated wastewater for land application can provide nutrients for plant growth and reduce high-quality water use. Currently, there are three primary types of wastewater for reuse. One is treated sewage wastewater. Two is treated domestic wastewater for rural community. Three is wastewater from large animal farms. This wastewater, even after treatment, they still have a lot of contaminants. My research work most focusing on passenger like E. coli and pharmaceutical and personal care products, PPCPs. For the PPCP contaminants, they mainly come from human and animal exclusion, also from the waste disposal. So don't dump any medicine in the toilet. Don't like this guy pee in the river and poison our water supply. Because the occurrence of PPCP in the aquatic environment will impact water quality. For example, some PPCP show very high acute toxicity to the aquatic species. Some PPCP are classified as a highly potent endocrine disrupting chemical because they can strongly interfere with the normal function of the endocrine system. If you want to build a muscle like these guys, you need a workout, no medicine. Using the used water for irrigation have a potential to loading passenger and the PPCP into the fresh produce, which caused many outbreaks of foodborne illness in the United States. Recently, internalization of food contamination in fresh produce is receiving great attention. Once this contaminant enter into the vegetable and the food, no one can wash out. Of course, you can use cooking to kill or internalize the passenger. But for PPCP, there are no way can completely eliminate by the cooking. Also, the cooking will, after cooking, a lot of nutrients in the fresh produce will be lost. Also, if you're not, by the way, if you're not a good cook like this guy, you will be waste all the food. So we need to prevent the PPCP. And this study to investigate uptake and internalization of the PPCP and the passenger in fresh produce that are irrigated with reduced water, prevent their loading to the environment. Currently, we are working on the PPCP plant uptake. We haven't started passenger research yet. In this study, we selected 10 PPCPs. First, we need to develop analytical method. There are two challenges for method development. One is a complex matrix. Second is we need a low detection limit from PPT to PPM. You may realize how low for the detection limit. If we use the money to count, you may be easy to understand. For 1 ppm, kind of like a 1 cent reduction in 10,000 transactions. For 1 ppm, kind of like I ask you to find a needle in a health steak. For the 1 ppt, if, for example, I'm a rich guy, I have $10 billion, I can buy 100 most expensive house. You ask me donation, but I just give you 1 cent. How do you think? So based on our developed method, we are conducting a greenhouse experiment to investigate the potential uptake and internal transfer PPCP in the vegetable grew in a hydroponic system. Based on our the priming data, we find all the PPCP can uptake by tomato plant. Their concentration in the roots, stem, and the leaf are strongly associated with the chemical properties. Finally, I will thank you USDA and Illinois Hazardous Waste Research Fund for supporting this study. Also, I want to thank you, my two little editors. I welcome any comments, questions, especially collaboration. Thank you.